Okay, let's talk about everybody's favorite fats. So 3.1.6 wants us to remember. So remember, I'm saying remember a lot. Remember that every time you see the word state, basically it's just asking you to remember. So we need to remember that the composition, we need to remember the composition of this molecule called TAG or triacylglycerol. Also, I think we might just be familiar with this word triglyceride. So they're all kind of the same thing. But in SEHS, they want us to remember like this triacylglycerol. So basically, I'm going to call them triglycerides. Oh, whatever. We'll call it TAG. TAG is how we store energy, and we store it as fat. And it's a preferred way, and it's stored in a very specific type of cell called adipose cells or adipose tissue. So those are your fat cells, and they just fill them up with these triglycerides. So it's made of two main parts. So the first part is the glycerol molecule. So this is like the scaffold that holds everything together. And a glycerol molecule is made up of 3 carbons, 2, 3. These carbons are bound to an oxygen and a hydrogen. Many times in chemistry, we don't bother showing the bond between the oxygen and the hydrogen. And then it is the other 2 are connected to a hydrogen. This one's connected to a hydrogen. This one's connected to a hydrogen, and another one here. So I don't know how much chemistry you guys have, but carbon is only allowed to form bonds with 4 different molecules. So if we looked at this carbon, for example, it's bound to a hydrogen, a carbon, an oxygen, and another carbon. So it's only bound to 4. So that's maybe one way you can remember how to connect those. So that's our glycerol. That's our glycerol molecule. I'm going to erase this, and we'll come back to this later. The other component of this tag, this triacylglycerol molecule or triglyceride, is the fatty acid part. So fatty acids are basically a long chain of carbons and hydrogens that kind of go on forever. And then at the end, and each one of these carbons are connected to a hydrogen. So remember, we talked about how carbon can form 4 bonds. So we just put a hydrogen in each one of these. And at the end, and this can be any length, I only made mine 5 carbon long. At the very end, there's this something called an acetyl group, where it's bonded to a double bond to oxygen, and then the other one is bound to the oxygen and the hydrogen. I drew the bond there that time. So that's the basic structure of a triglyceride or a tag. So when we draw this, now if you notice the word tri, it's basically 3 of these fatty acids connected to the glycerol molecule. So let's show how that looks. So let's draw our glycerol molecule first. Glycerol, when we're just drawing it in notation, instead of drawing all the carbons and the OHs and the Hs, we just draw like a line with 1, 2, 3. So if you can picture this, in the middle there are carbons, and these would be our OHs, if you remember. These would be where the hydrogens are. And then we connect them to the fatty acids. And the fatty acids, we draw them basically as just squiggly lines like this. I don't know why. So you can think of these as different carbons connected to the hydrogens with that one OH, that one carbon double bond to the oxygen and the OH. So we can draw fatty acid number 1 here, fatty acid number 2 here, and fatty acid number 3 here. So that is the basic structure of tag, right? Tri means 3. What do we have 3 of? We have 3 fatty acids. And each of these fatty acids are connected. There's bonds here. Each of these fatty acids are connected to our glycerol molecule.